the test force, the indenter automatically lifts off again and the microscope lens pans back to its former position. The indentation can now clearly be seen on the monitor. With the control knob, the tester places 4 measuring lines on the edges of the indentation to measure its diameter. That's it. The testing machine can now calculate the Brinell hardness. The hardness value is defined as test force F in the old unit kilopond divided by the area of the indentation A in square millimetres. The result is displayed on the bottom left.
Hello.
Good morning, Monada. Now I will explain the Hardness test with the help of the Brinell Hardness test term. Then there are two methods, there are two measures, the materials we are going to test with the help of this fellow, ferrous as well as non-ferrous material. Now I will choose, that is the brass material. Then first I will place the brass material onto the anvil of the tester. With the help of the hand feed, we are going to raise that is the specimen. Before I will conduct the test, I will go and choose the load. What is the load we are applying onto the ferrous as well as non-ferrous? The brass we are using, for the brass we are applying load is 1000 kg. That means pan, it is a 250, another one, another 500, that is the 250, once again 250. Total is 750 and inbuilt, that is the inbuilt is containing a weight of 250. Totally the effective of 1000 kg is going to be acting onto the indenter. This is the indenter we are fixing the indenter knob, that is the indenter holder. The indenter we are using is the steel or carbide steel ball indenter we are using here. The diameter is 10 mm. For the different diameter balls we are using for the different load we are going to use. But now we are using the 10 mm ball. That is the load we are applying. It is the 1000 kg with the help of the weight pan. Then effective transformation of the load is transferred to the indenter. Then switch on the machine. Once switch on the machine, then raise the anvil with the help of the anvil. Once it touches the indenter specimen, then I will set the minor rod, then I will rotate the anvil, then the smaller indicator will come slowly till it touches the red dot in smaller needle. The smaller needle in the smaller dial gauge, it touches the red dot, that means minor load, that is the 250 kg is acting on the specimen. Then slowly I will apply a load with the help of the load transfer lever. Then we will give the dwell time for the 5 minutes till there is a big indicator which is going to be show the movement of the needle. Then it comes to the stagnant. It is going to be stable and stop at one particular point. Then until 5 minutes, depending upon the different material, we give the time. That is the dwell time. After the 5 to 10 minutes, it stops. Once it stops, we release the load, then we take out the specimen. After 5 minutes, release the load. Then once again, in anti-clockwise rotation, we retract back the anvil, take the specimen and switch off the machine. Then there should be an indentation mark is appear onto the specimen. With the help of the chalk piece, we mark that one. Once the mark takes place on the indentation, with the help of the traveling microscope, we take out the D1 value, diagonal 1, in other direction diagonal 2, then take the average value of that. Then with the help of the BHL formula, it is written here, 2p divided by pi d into d minus square root of d square minus small d square. With the help of this formula, we find out the BH number. Here, P is the applied load, that is the brass, we are applying 1000 kg. Then D is the diameter of the indenter, that is the 10 mm diameter, steel ball indenter. Then small d is the average indentation diameter, it is appear onto the specimen, that is the indentation mark. With the help of this formula, we find out the BHN number. For the different load, for the different material, for example, aluminum, we are applying load is 500, brass, the intermediate material, the copper, brass and bronze, 1,000 to 1,500. And the hard material, caster and magistry, where apply load is 3,000. With help of this force and you repeat the procedure as like the
This is a Brinell hardness test. So using this experiment, objective of
Hello, sir.
aim of this experiment is to determine the Brinell hardness number of given aluminum and cast iron sample. Tools required are Brinell hardness testing machine, ball indenter, and Brinell microscope. So procedure, there are 7 steps in the procedure. The first step is we have to fix the load and duration of application of the load. So here there are 4 different metals are given. So we are going to use first metal is ferrous. For ferrous, the corresponding load is 3000 kg and the time is 15 seconds. Time of load is 15 seconds. Again, we are going to use aluminum. For that the load is 1000 kg and the time is 15 seconds. So this for steel we use 3000 kg 15 seconds and aluminum 1000 kg and 15 seconds. This is a standard value. Next, this is a machine, Brinell harness machine. Here we have a dial. Here we can for initial setting. And here we have to fix the workpiece. Above that we have the indenter. Here there is a wheel. By this elevating screw, by rotating the wheel, the workpiece can be moved upward and downward direction. If you rotate clockwise direction, it will move upward. If you rotate the wheel counterclockwise direction, it will move into downward direction. Again, here we have the loading knob, loading unloading knob. When you rotate in clockwise direction, the load will be applied on the workpiece by the indenter, and if you unload it, it will be removed. Right. Next is you have to select the weight. Already I told you how much amount of weight is to be applied. So this is a place you got to apply the load. So for aluminum you have to apply 1000 kg, and after for steel you have to apply 3000 kg. So after that you have to press this button, then load will be applied. So it's a hydraulic system. Here this is a place we have to fix the workpiece. So by rotating the wheel, the screw can be moved upward, and the workpiece will come in contact with the indenter. So once the indenter is having the initial contact, here there are it's a big dial. Inside there is a small dial, and indicator is also there. So when the initial setting is over, that can be confirmed by indicator, and the red spot has to coincide. The indicator has to reach the red spot. Then the setting is over. So now the initial setting is over. So after that, we have to apply the load. So this is a loading knob. You rotate clockwise direction, load will be applied, and you wait for 15 seconds. After 15 seconds, you remove the load. So now after load is removed, you take the workpiece, and this is a microscope. This is a Brinell microscope. You can this purpose of the Brinell microscope is to measure the diameter of the indenter. So after indentation is formed, you use the microscope to find the diameter of the indentation. Already we know the diameter of the indenter. It is a 10 mm. So now you find the diameter of the indentation using this microscope. After that, you got to do the calculation. This is area. This is a area of indentation. Area that can be calculated using this equation. Here, capital D is diameter of the indenter. How much it is? 10 millimeter. Diameter of the indentation that you have to measure from the microscope. And you substitute all the values in millimeter. So substitute in millimeters. Similarly, the load you substitute in kg. So Brinell hardness number is load divided by area. Area you can substitute from here in millimeter, load in kg. So it will give you a number. It doesn't have any unit. It is a number, Brinell hardness number. So that will give the indication of hardness.
Stop share.